Hello, Assalamualaikum warahmatullahi wabarakatuh. So today we are going to present about OSH and manufacturing site visit. What we found after our site visit last week. So last week we went to 3D Gens Sdn Bhd that is located at 18 Jalan Kerawang U8/108 Bukit Jelutong, Shah Alam, Selangor. This is my group members. So firstly is Muhammad Afif Hilmi bin Muhammad Nazmi. Next is Ahmad Luqman Hakim bin Mahazir. Next is Mima Asaf Ahmad Muhammad bin Nazri. Fourth is Aman bin Ahmad Fazli. And lastly is Hezri Shafri bin Rizwan Shafri. So for the third slide is about a brief about the company of 3D Gens Sdn Bhd. So the company name is 3D Gens Sdn Bhd, also known as 3D Generation. The company is established on April 20th, 2016. Their headquarters located at Shah Alam, Selangor, Malaysia. International footprint is from London, UK and Indonesia. And the founder and managing director is Dr. Izhar Abdul Aziz. He is well known for 3D metal printing, and he also received award for his PhD in 3D metal printing. So lastly is the nature of the business is medical digital manufacturing, industrial rapid prototyping, 3D scanning or reverse engineering, and lastly is professional additive manufacturing training.
Okay, so now I am going to present about the brief history of our company 3D Gens. Okay, so the first one, the academic roots of this 3D Gens. So it was founded by Dr. Izhar Abdul Aziz. He graduated from University Malaya, and then he earned his master's and PhD on 2012 at University of Waikato, specializing in 3D metal printing technology. And then he returned to Malaysia with advanced expertise in additive manufacturing. He also identified Malaysia's heavy dependence on imported medical implants from Western countries, and then recognized the need for a local, cost-effective and faster solution for producing complex medical implants. And then it was at the beginning of 3D Gens. 3D Gens was officially established in 2015, around 2015 and 2016, founded by Dr. Izhar himself with a vision to localize advanced 3D metal printing. They started with only 46,000 ringgit or $10,300 US, borrowed from family, operated as a bootstrap startup with limited financial resources, and then they faced early market skepticism due to the low awareness and adoption of 3D metal printing technology in Malaysia. So the turning point of the company, it happens at 2017 to 2018. A major breakthrough came during an emergency situation. A public hospital urgently needed custom implants and medical parts. The emergency allowed the hospital to bypass the lengthy tender process. 3D Gens secured its first major contract worth 300,000 ringgit. This milestone demonstrated the company's capability and accelerated its commercial growth. And then they expand and the mainstream success. Introduced the Logic Patient Implant PSI system as its flagship innovation. Revolutionized the production of patient-specific medical implants. Improved the treatment of craniomaxillofacial (CMF) conditions, including skull and jaw reconstruction. Enhanced surgical precision, reduced lead times, and improved patient outcomes. And they also strengthen 3D Gens' position as a leading medical 3D printing company in Malaysia. So what is the company 3D Gens do? What do they do? So this is what they do. First one, They are doing medical application and digital dentistry. They are the most famous for their logic patient implant PSI system. They make custom implants. They map patient anatomy using CT scans to 3D printed tailored titanium bone replacements such as skulls or jaws. And then they also do surgical guides. They print highly precise pre-surgery models so surgeons can practice and map out incisions before entering the operating room, cutting hours of critical surgery time. And that second one, they also do industrial engineering and prototyping. They serve sectors like aerospace, automotive, and oil and gas by printing and used parts, jigs, and custom inspection fixtures. They also have the tech capabilities of using FDM, fused deposition modeling, SLS, selective laser sintering, and direct metal laser sintering, DMLS. They also have advanced materials. They, they are printing using complex materials including titanium, Inconel, cobalt chrome, stainless steel, and PC ABS. And also, there's the one material. It's called PEEK. It's hard, but it's so expensive.
Assalamualaikum. My name is Ahmad Lukman Hakim, and I will continue the presentation for what they do in this industrial. So first and the third, they provide the material R&D and authorized distribution. And one of the other material is rubber-based polymer, which is they collaborating with the Malaysian Rubber Board, which is in Lembaga Getah Malaysia. They conduct extensive R&D to develop flexible, printable rubber materials for industrial use. And also they provide hardware distribution, which when they act as an authorized distributor for industrial grade polymer and metal 3D printer across the region. For the next part is types of manufacturing. One of the manufacturing in our country that used in our industrial, which is subtractive manufacturing, or we call it machining. This process, we start with a solid block of material like a metal, wood, or plastic, and use a sharp cutting tool to shave away the layers until the final shape achieved. One of the method, we call it CNC milling, turning, drilling on, and laser cutting. The next manufacturing, we call it additive manufacturing. For this company, we use it 3D printing. This manufacturing, instead of cutting away the material, additive manufacturing builds an object layer by layer from zero to the final design. One of the methods is use fused deposition modeling (FDM), selective laser sintering (SLS), and direct metal laser sintering or DMLS. For the next part is formative or molding manufacturing. This process using extremely heat and pressure to force a liquid or pliable material into a pre-designed cavity or mold. Once the material cools or solidifies, it takes the shape of the mold. One of the method is injection molding, used for plastic bottle or toys. Casting for heavy metal like engine blocks, and also a fogging process. The analogy of this manufacturing like making an ice cube, like by pouring water into a tray and you freeze it into a refrigerator. Okay. The next part The next manufacturing is assembly or joining manufacturing. This process involves taking multiple distinct components, which may have been created using subtractive, additive, or formative methods, and joining them together to create a complex finished product. One of the methods that using this manufacturing is welding, soldering, adhesive bonding, also mechanical fastening, like using screw or rivets. This manufacturing, like when you building a Lego. Next point is manufacturing process. 3D gens utilize end-to-end digital additive manufacturing workflow that transform digital CAD designs into a physical components. Unlike traditional CNC machining, which that remove the material through cutting or remove the parts, additive manufacturing builds part layer by layer. It also reducing material waste while they enabling the production of complex, high precision and customized components.
So, Assalamualaikum. My name is Jesus Shafi bin Rizwan Shafi, and right now I will present to you the technology employed by 3D gens. So, there are three types of technology. The first one is direct metal laser sintering, which is DMLS, or you can call it powder bed fusion, PBF, which is a high-powered fiber laser fuse fine medical grade titanium and cobalt chrome powder layer by layer. The next is fuse deposition modeling, which is FDM, and also selective laser sintering, SLS. And the picture is the machine shown, which is used for polymer-based engineering components for prototyping and pre-surgery training models. The third is the 3D scanning and reverse engineering, which is high-precision optical scans that is able to capture physical parameters received from CT or MRI scans from vendors and customers such as hospitals that need it for surgery. So in general, people would say that 3D printing company wouldn't have hazards or risks. However, 3D Gens has a practice of safety techniques inside their company because such as handling fine metallic powder, it requires strict explosive safety and respiratory protocols. That is why 3D Gens make sure their operators wear specialized PPE, which is positive pressure mask and also anti-static gear. Next is the industrial printers are run tightly and safely in control rooms because they use inert argon gas that is dangerous to humans, and in order to prevent dust explosion hazards or oxidation. And as you can see the pictures, there are pictures of masks, there are pictures of no smoking, no flammables because there are argon gas, and also there are signs attached on the walls of wearing PPE, and last but not least is the first aid kit being portable at the wall in case if anything happens. So let's talk about design concept and quality assurance. So for 3D Gens company, the design concept is additive manufacturing, which is adding materials, or we can call it adding process to produce something. This is different than engineering methods such as subtract engineering, which is subtracting materials that can produce waste, such as producing materials by stamping. So, however, their core philosophy revolves around patient-specific personalization, which is mapping implants exactly to patient's CT scan, such as the shape of the skull, and topological optimization, which is reducing structural weight while maintaining their mechanical strength. So 3D gens will play with a lot of different materials to fit the pricing and also the quality of the product. So let's talk about the quality assurance. So since they manufacture critical human implants, their QA framework is very highly regulated. They maintain strict certifications under ISO 13485 medical devices manufacturing and ISO 9001 2015. They use process simulation software to make sure they analyze the thermal stress and prevent warping before build begins, followed by post-spin inspections using non-destructive testing. So let's look at the product produced by 3D Gens. First of all, let's look at the medical and dental products, which is, as you can see, these are the pictures of titanium skull plates, which is cranioplasty, mandibular or maxillofacial jaw implants, customized surgical cutting guides, and ergonomic clinical tools such as customized camera laryngoscopes. So 3D Gens has told us that they are receiving from their customers to make this type of materials because they can produce complex parts easily. So these are their strengths. That is why they can customize CT scans for their customers. But besides the medical and dental industry, they also produce in the industrial engineering side, which is a small batch of functional components, custom inspection jigs and fixtures for the automotive sector or aerospace prototypes, and also some material testing specimens. So as an examples, there is one motorcycle company has come to 3D Gens to produce a niche custom parts needed for them to upgrade the spec of an engine. So mass producing will be so expensive. That is why they ask 3D Gens to custom-made it fast and easy and also strong. That is all.
And now we will talk about problem faced. First one is a thermal distortion and warping. During high heat metal laser melting, rapid heating and cooling cycle create residual stress that can cause part to warp, lift from the wood plate or crack. Second one is a porosity and internal micro defects. Imperfect laser parameters or powder contamination can entrap micro void or gas bubble, resulting in an internal porosity that compromises the mechanical fatigue life of a load-bearing implant. Third one is a surface roughness. As a printed metal item have a texture sandpaper-like finish which require extensive manual post-pressing to reach medical grade smoothness. Let's go to the next part. Discussion. First one is a technology comparison. Traditional metal manufacturing like CNC machining is highly efficient for mass production but struggle with complex internal cavities and waste up to the 80% of the raw material in shavings. 3D Gen's choice of additive manufacturing is superior for their specific business model because it allows complex customization without expensive molds, prints geometric patterns impossible with CNC, and save expensive titanium powder waste. Second one is overcoming operational and technical challenge. To defeat thermal distortion, 3D Gen can use advanced thermal mechanical print simulation software like Autodesk Fusion 36mm modules to model stress hotspot and digitally add counter deformation or optimize support structure prior to physical printing. To resolve internal porosity defect, the company relies on the strict feedstock traceability protocols, ensuring printing powder moisture levels and grain size are carefully tested using morphology scanners before reuse. Continuous quality improvement. To maintain their competitive advantage and medical precision, the following continuous quality improvement initiatives are recommended. The first one is the automated quality assurance frameworks. Transition from manual optical part measurement to AI-driven in situ layer monitoring system. Thermal cameras inside the printing bed can flag defects or anomalies instantly mid-print, reducing scrap rates. Second one is a standardized operator upskilling. Expand structured training courses like the International Powder Bed Fusion Laser Beam Operator qualification internally across all the production technicians to reduce human error defects during machine setup and powder handling. Last one is an advanced surface post-processing automation. Invest in automated chemical, accelerated smoothing or electropolishing system to reduce the bottleneck and human variable of manual grinding or polishing on the complex geometries. So, as you can see, here the evidence of our site visit. So, this is the end of the video. I hope you guys enjoy our video, and that's all for us. Thank you very much.